Wham bam. We've got this tree. And what are we trying to do with it? The moment about O of the resultant force exerted on the tree by cables at B. So we got a few cables at B. So I'm assuming that you know, this is some old lady's house on the other side of this, right? Draw a little window here. This is going to be an open window. I have a window sill. On that window sill, there's going to be pi. Now we have to stop this tree from hitting that pi, right? And we're doing this by taking these cables and we're going to pull the tree down this way. Okay, this one's directly down and away from the pi. And then this one's the other way in case it wants to, I don't know, fall side to side and it might hurt the pi, but play it safe. Let's play it real safe. So with this, we're also given that the tension in AB and the tension in BC, okay, we're given that tension in AB is equal to 655, and the tension in in BC is equal to 760, and these are both in newtons, right? And we want to take the moment about O. So I think this might involve lambda vectors. Something about this just screams lambda. The thing that screams lambda is that we're given distances from and to points. So let's just start with that whole fun thing. Let's do it here because we've got some space. We're gonna have points A, B, and C. So it's really not all that many. And of course, it's gonna be an X. There's gonna be a Y. And there's going to be a Z. So in the X for A, we're going to have negative 0.75. For Y, we're going to have 0. And in fact, we're going to have 0 for C as well, but we haven't gotten there quite yet. So for Z, we're going to have 6. And I guess we'll also put the, well, we're going to have force vectors and then magnitude, so this is going to be crazy nonsense. So now point B is going to be 0, positive 7, and X, Y, Z, 0. Okay, it's just straight above the origin. And then point C, that's going to be 4.25 in the X, 0 in the Y, and one in the Z. So now we're going to find a vector AB and vector BC. I keep doing that. It's going to be B minus A, so it's going to be a 0.75. Then it's going to be 7 minus 0, which is 7. And then it's going to be negative 6, because it's going to be 0 minus 6. And then BC is going to be 4.25. 0 minus, that's going to be minus 7. Which is interesting. But it's what it is. And which I don't agree with. Just don't agree with it. I think this is going to be wrong, and I think that's going to be the reason it's going to be wrong, but I can't stop it from being wrong because that is just what it is. So if it's right, then it's all going to be very fine, but I don't know. And then 1 minus 0, so it's just going to be 1. Now we're going to have the magnitude of AB and the magnitude of BC. And that's going to be the square root of 0.75 squared plus 7 squared plus 6 squared. That's going to be equal to 9.25, and then this one's going to be the square root of 4.25 squared plus 7 squared plus 1 squared, which is going to be equal to 8.25. So now lambda AB is going to be equal to, and then lambda BC is going to be equal to. This will give us an x, y, and z, and then we'll have the force of TAB and x, y, and z. And from there, we can do distance cross force, a moment r cross f. So, yeah, this is all coming together. We're going to have 0.75 plus 7 minus 6, all going to be divided. And then this one's going to be 4.25, that looks like a 9. Minus 7, 1, and all going to be divided. And that should be I hat, J hat, K hat, to be honest with you, but I forgot that step. Doesn't truly matter, but it does help out a little bit. And this is going to be TAB multiplied, and this one's going to be TBC. And now this here is our force vectors, so that's good to have those. So now we have the force vectors. That's F. We have to do R cross F for all of these. And this is where we probably just plug this straight into like a matrix equation, right? That would be the fun thing. Because we're going to have an I hat, J hat. But how do we do a matrix equation? To solve for a moment. I don't think we can plug this into a matrix equation. Unless, well, what are we looking for? We have TAB and TBC, and we have the force directions in IJ and K hat. The forces, we need to know the distances. I think that's where I'm really getting stuck here now. I mean, technically, all of those forces are at B. We have point O, and we're going up, and then right here's point B. That's where all the cables are. So we're gonna have an X, a Y, and a Z. These are gonna be all of our forces. That's gonna be X. That's FZ, and this is gonna be FY. Those are gonna be all at B. So that's the distance right there. Is that as simple as it is? So now what we can do is the moments, the moment about O. Let's see. I don't think this will this have a Y component at all? I don't think it will. Let me check. No, it won't. Okay. So then this would be force 0.75 over 9.25. And of course, this is going to be X, Y, and Z. That would be this force here. And this would be times 655. Let me just times or cross. No, I think this looked better. Times. That's F. We should have started with R. Really. So I'm gonna redraw this. I think in my head a moment is always R cross F, so I want to stick with that. The distance is gonna be 7 times 655 times 0.75 over 9.25. And that's going to be, let's see, is it clockwise and counterclockwise? From what? From the x-axis, this will spin it. Well, it should spin it counterclockwise. That should be positive. And now we're going to have minus 7 times, and this one's going to be 760 times 4.25 over 8.25 TBC, and that's the force. So this should give us our I hats. We're doing R cross F, so it's going to be 7 times 7. Okay. And I'm getting, boy, if this is somehow wrong, and then 2, 3. Wish there was a show answer button. I'm gonna try to put this in as a 0.9 maybe. No, I think something's up. I think something's just wrong. So I did TAB in the X direction, TYZ, Newton's meters. We're given things in meters. $760.65, those are all good. 9.25, 8.25, those are all looking good. I'm gonna try one more thing and then I'm gonna look deeper into this. Yeah. Give me a second. Just as I subsected that they call it cable T AB and cable T BC, but they are in fact retarded, and I should not listen to the problem. This should be cable BA, because we called it something completely different for no good reason. Or this one should be CB. Either way, they have to be kept the same. And this problem didn't do it that way, and then was shocked when it wasn't wrong. It's like, oh, I told you the wrong thing and you got it wrong? They call it AB and BC, man. Why can't it be AB and BC? Gosh. This is actually going to be negative here, and that means that this should also be, let's see, negative, and that should be positive. Which doesn't change the magnitude, but it does change this. It should be negative. That should be negative and that should be positive, and this changes everything because now this is going to be negated, and that I think I started out with that being added. Maybe I didn't. Hold on. If they think it might actually be subtracted. Actually, I think the negative sign, I don't know if it changes anything, but it should maybe go here. I don't know. Yeah, it doesn't seem like it changed enough. Oh, and let's see. That's negative, that's positive. Oh boy. Give me another moment then. Okay, yeah, indeed, I was wrong. So we need to have a resultant force or some kind of a force that's the summation, I guess, or some other big stupid fancy made up word that just means that TAB and TBC, or in this case BA, are one. We need to make them one so that we can cross it. We need to do R cross F. So we need to find what that F is going to be, that force. So then all we need to do is say that this is FR, and what that's going to be is these two. We're going to have a negative. Let's see what these combine up to. Okay, this just gives me a number. So this is going to be 444.6 I hat, and this is going to be minus, because J hat's minus. And this is going to add to be positive. B. Yeah. This is gonna be negative. Wait. We're adding two negatives, which is a negative, but because j hat is negative, it becomes a positive. So this would be 1140, but you know what? Doesn't even matter what this is anyway, because j hat turns out to be 0. And then k hat. It'd be 6 that side, and then 1. I'm gonna get 516.98 k hat. Okay, wonderful, splendid. Now to do r cross f. It's not even close to enough space. Hold on. I can do trickery. Look at that. Magic. So R is going to go on top, and it's going to be 0 I hat. It's going to be a 7 J hat and a 0 K hat. And now we're going to have negative 444.6 and, you know, whatever, W, just to make it a funny face. Because it's going to be 0. No, wait, we might have to use it for other things. 1140. And then 516.98. Okay. With this, I hat 7 times that minus, so I'm going to take this number and multiply it by 7. So that's giving me 3618. Hey, wait, is that already the answer? Let me see. Oh no, I can't. Yeah, that's the answer. And then J hat's 0. K hat. It's gonna be 0 minus, so it's gonna be 7 times. Where did we even get all those 4s from? I'm getting 31,112. Whoa, 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 way off. Way off. A hat would be 0. Subtract, yeah, where did all those 4s come from? Let me vet this. Wait, should be negative. It shouldn't change anything though. Well, it might, because we're adding. Yep, okay, it does change everything. So this is actually, because 0.75 is negative, this is actually 338.3, which changes this to a 236. Gosh, no, 2,368.8. Yeah, all right. And that is what it asked for, finally, after all this time. That's the problem.